Good day! So today we'll look at examples of problems that involve the definite integral. So let's start. Our first problem is the definite integral from 0 to 1 ng x squared. So first, let's answer kung ano ba tong expression na to. This expression represents the area of the region bounded by the function y equals x squared, yung x-axis, on its left side yung x equals 0, and on its right side yung x equals 1. Okay, so here we have a graph of the function y equals x squared, tapos nag-drawing na tayo ng approximating rectangles sa kanya. Here we have n rectangles, tas in the interval 0 to 1, we have n sub-intervals, so that would correspond to the n rectangles. And for this example, yung height nung ating approximating rectangle, gagamitin natin yung rightmost point of the subinterval para i-determine siya. Ano ibig sabihin nun? Kung ano yung value nung x dun sa pinaka-kanan na point ng subinterval, siya yung x sub I natin. Yung magiging basis ng f of x sub I para ibigay sa atin yung height nung rectangle. So that would mean that our first subinterval, yung 0 papuntang 1 over n, yung x sub I natin sa kanya will be 1 over n. And correspondingly, yung x sub 2 will be 2 over n, x sub 3 will be 3 over n, all the way hanggang kay x sub n, which will be equal to n over n. Ano ulit ibig sabihin nun? Yung nth rectangle natin, yung nth subinterval, yung height niya, yung nasa pinakakanan, which is yung n over n or 1. So f of 1, yung height ng rightmost rectangle natin. So, ang convention natin ay ang x sub I ay equal sa I over n. And let's not forget that our delta x here will be given by yung b minus a over n or 1 minus 0 over n or 1 over n. So, let's write down our Riemann sum. The Riemann sum, r sub n, this is equal to the sum of all the f of x sub I times delta x. So, this is the summation from I equals 1 to n of f of x sub I. So, yun yung height ng mga rectangles natin times yung base nila, yung width, yung delta x. And since yung bawat x sub I natin is given by I over n, we could rewrite this as the summation from I equals 1 to n ng I over n quantity squared. So, pinasok na natin yung x sub I sa function times delta x, but delta x is equal to 1 over n. Then, we observe here that 1 over n is just a factor nung bawat terms dun sa summation. So, pwede natin siyang i-factor out. We'll rewrite this as 1 over n times the summation from I equals 1 to n ng I squared over n squared. Oops, I have to rewrite that. Okay, there we go. I over n quantity squared. Then, let's expand the summation. This will be equal to 1 over n times 1 over n quantity squared plus 2 over n quantity squared plus and so on all the way hanggang kay n over n quantity squared. Applying yung square, we will get 1 over n times the quantity 1 squared over n squared plus 2 squared over n squared plus and so on all the way hanggang kay n squared over n squared. And for all the terms dun sa loob ng parenthesis, lahat sila may n squared sa denominator. So I'll also factor it out para imbis na 1 over n yung nasa labas, 1 over n cubed na. At yung matitira sa atin sa parenthesis ay 1 squared plus 2 squared plus 3 squared and so on all the way to n squared. So yung value, yung expression sa loob ng parenthesis, we call that sum of squares. And from Math 4, I think gumamit tayo ng proof by induction para makahanap ng formula for the sum of squares. So I prepared another video that gives us another method of coming to the formula for the sum of squares. So, I'll link the video somewhere here. I think makikita nyo siya as thing na rectangular kung nasa YouTube tayo. Kung sa LMS natin, I'll just post it below. At sinali ko siya actually sa isang contest sa Summer of Math Exposition, the first such event. Anyway, let's just use this formula. Let's assume na naalala natin yung proof or pinanood natin yung isang video. This will now be equal to, our expression will now be equal to 1 over n cubed times yung sum of squares formula, n times n plus 1 times 2n plus 1 all over 6. Expand natin yung numerator. This will be equal to 2n cubed plus 3n squared plus n all over 6. Ilalabas ko yung 6 sa denominator. Ipapasok ko yung n cubed dun sa expression para makuha ko yung 1 over 6 times the quantity 2n cubed over n cubed plus 3n squared over n cubed plus n over n cubed. Then let's simplify everything dun sa square brackets, we'll get 1 over 6 times 2 plus 3 over n plus 1 over n squared. Distributing yung 1 over 6 sa labas, we'll get 1/3 plus 1 over 2n plus 1 over 6n squared, and this is equal to the Riemann sum. Now, hinahanap natin is yung the definite integral, no? Not just the Riemann sum. So, let's recall that the definite integral is the limit of the Riemann sum as n approaches infinity. This will be equal to the limit as n approaches infinity of 1/3 plus 1 over 2n plus 1 over 6n squared. But let's go back sa math 5 natin, and ano ba yung nangyayari if we take the limit ng isang fraction na yung denominator niya nag-a-approach ng infinity? Then that whole fraction, that whole expression will approach 0. So our second and third terms will approach 0, and the limit of 1/3 is 1/3, so we'll just get 1/3. Or we'll get that the definite integral from 0 to 1 of x squared is equal to 1/3. Now, we know that this represents the area bounded by the function, the x-axis, the lines x equals 0 and x equals 1. So, yung area pala na yun, ang measurement niya is 1/3. Now, we know that area siya, pero we're not measuring it as an area in the sense na we need to give the square units. When we compute for the definite integral, we just usually give the value unless we're specifically asked to find an area. So we don't need to say 1/3 square units. We'll just say that the definite integral from 0 to 1 of x squared is equal to 1/3. And let's move on to the next example. For our next problem, we're being asked to find the definite integral of the square root of 4 minus x squared from -2 to 0. But here we are helped by our familiarity with the equation na y equals square root of 4 minus x squared. This is an upper semicircle na nakasenter sa origin at may radius na equal sa square root of 4 or 2. So let's draw a figure representing that. Sorry, hindi ko na ginamit yung nice na manim na pang-generate. Kinamay ko na lang. Okay, so this is the graph of an upper semicircle. We want to find the definite integral from -2 to 0. So hinahanap natin yung area ng region bounded by the upper semicircle, the x-axis, and the lines x equals -2 and x equals 0. So, yung nakamark sa green. So, the definite integral from -2 to 0 of the square root of 4 minus x squared is the area nung region na nakamark dun sa figure. But, ano ba ang area ng circle? Diba? It's pi r squared. So, we want the area of 1/4 of that circle. Is 1/4 of that circle. So, that is 1/4 times pi r squared, and we'll use that our radius is equal to 2. So it's 1/4 pi r squared. Evaluating r at 2, we'll get 1/4 times pi times 2 squared, and we'll just get that the definite integral from -2 to 0 of the square root of 4 minus x squared is equal to pi. So let's just highlight our final answer with a box, and let's move on to our third problem. For our third problem, we are looking for the definite integral from -2 to +2 of the quantity 2x minus 2. So this is a line with the slope of 2, tapos may y-intercept na -2. Let's plot the figure there. Okay, so here we go. Gumamit na rin ako ng approximating rectangles. So notice that the approximating rectangles for the region below the x-axis are marked in red, and the approximating rectangles for the region above the x-axis are marked in blue. So my next question is, before I proceed, ano ba yung ibig sabihin ng region below the x-axis in terms of the definite integral? Kasi sabi natin, it's supposed to be the area, diba? And area, as we know, is always positive. But we'll have a different approach, if we're looking at the definite integral. Kasi, how did we get the area or yung area ng isang approximating rectangle? Sabi natin, this is the product of the function evaluated at some x dun sa ith subinterval. So a sub I, the area of the ith rectangle, is equal to the function evaluated at some x in the ith subinterval times yung width niya na delta x. Now here, our delta x is 2 minus -2, so 4 divided by n kung ilang rectangles meron tayo. So that's 4 over n. That's positive. That's a positive value. But our x sub I sa region below the x-axis, if we evaluate yung function value sa kanya, magiging negative siya kasi you're looking at the function value yung pinaka-value ng function, below nga siya the x-axis. So, f of x sub I will be negative. So, yung area na yan, a sub I, will be negative. So, when we say the definite integral sa isang region below the x-axis, it is negative. Even though we don't have a concept of negative area, that value itself, while it is based on area, it will be negative. The definite integral will be negative. So, when we want to find the definite integral of this region, hindi natin i-add yung areas ng dalawang triangle, yung below the x-axis at yung above. So, we'll get the area of the triangle below the x-axis, we'll get the area of the triangle above the x-axis, then iti-treat natin negative yung value nung area nung region below the x-axis. So, add natin sila. So, here we could predict, no, since mas malaki yung region below the x-axis, which means that yung definite integral niya ay negative. Pag kinumbine natin sila, then the total definite integral of this function from negative 2 to positive 2 should be negative. I think you know that this is a video that I'm playing tas tinatry kong i-narrate. I messed up dun sa unang video at may na-delete akong portion. So, nag-move ako dito na naisulat ko na siya and I'll just do some scrolling. Hindi ko na magagawa yung writing animation. So, apologies for that. Okay, so what we'll do here is we'll divide yung region into two triangles, the triangle below the x-axis and the triangle above the x-axis. Which means that we'll write the definite integral from negative 2 to 2 of 2x minus 2 into two parts. First, the definite integral from negative 2 to 1 nung 2x minus 2. This is the entire region below the x-axis. Tapos, the definite integral from 1 to 2 from 2x minus 2, which is the entire region above the x-axis. But these regions represent triangles. So let's just use the formula for the area of a triangle. It's 1/2 times base times height. Yung first triangle natin, yung below the x-axis, we know that it should be a negative definite integral. So it's negative of the product ng 1/2 times the base, which is 1 minus negative 2, so 3, times the height, which is 6. Pero diba syempre pa-negative yun, pababa. Plus, yung area nung second triangle natin, yung above the x-axis, so it's 1/2 times the base, which is 2, times the height, which is also 2. And we'll get that the negative integral from negative 2 to positive 2 of 2x minus 2 is equal to negative 7. So far, no, for the second and third examples, parang we were just using area formulas. But that's really just to introduce the idea. Hindi na siguro magiging ganito later on. Hindi na tayo nagko-compute lang ng areas ng regions na basic, like a circle or a rectangle or a triangle. Okay, so for our fourth example, we want to find the definite integral from 0 to 2 of the quantity x cubed minus 3x squared plus 3. So let's take a look at the plot of the function na y equals x cubed minus 3x squared plus 3. Okay, so here we go. Tapos nag-drawing na rin ako ng approximating rectangles. So similar dun sa previous problem, meron tayong region that will be above the x-axis and a region that will be below the x-axis. So what does this mean? This means that the definite integral from 0 to 2, no, of x cubed minus 3x squared plus 3 is not the total area nung dalawang regions, but parang yung net area nila. And in the figure, you can recall, mas malaki yung area nung blue, yung nasa taas, kaysa dun sa red, yung nasa baba. So we expect our final answer na definite integral dito to be positive. So let's take the Riemann Sum Approach dito. I-divide natin yung areas, yung interval natin from 0 to 2 into n sub-intervals. So that would mean that our delta x, yung base ng triangles natin, which is also yung width ng mga sub-intervals, will be given by 2 minus 0 over n, b minus a over n, or 2 over n. Similar to the other problems, we'll be taking the rightmost point of the sub-intervals. What does that mean? So kunyari, yung first sub-interval natin, ang width niya ay 2 over n, but it starts from 0. So, yung range ng sub-interval na yun ay from 0 to 2 over n. So, kunin natin yung pinaka-kanan, x sub I will be equal to 2 over n. And correspondingly, yung susunod, yung second sub-interval, kukunin natin si 4 over n, si x sub I natin doon, all the way hanggang dun sa nth sub-interval natin, yung pinaka-nasa right side, and kukunin natin sa dulo ng interval natin, which is 2. So, it also corresponds to 2n over n. So now that we have this in mind, we're ready to write a Riemann sum. So the Riemann sum is equal to the summation from I equals 1 to n of f of x sub I times delta x. Interpret naman ulit natin yon. This is the summation from equals 1 to n of f of x sub I times 2 over n. Now, let's factor out muna si 2 over n. This is equal to 2 over n times the summation from I equals 1 to n of f of, ano yung x sub I natin? 2i over n. Then, let's expand yung function. I-apply na natin yung idea na f is equal to x cubed minus 3n squared plus 3. So, this is equal to 2 over n times the summation from I equals 1 to n of the quantity 2i over n, quantity cube, plus 3 times 2i over n, quantity squared, plus 3. So, what we'll do is yung exponent, i-apply na natin dun sa mga values sa loob ng parenthesis. We'll get that this is equal to 2 over n times the summation from I equals 1 to n, ulit-ulit, of 8i cube over n cube minus 12, so 3 times 2 squared, 12i squared over n squared plus 3. Okay. Our next step is to distribute the summation sa lahat ng term dun sa parenthesis or square bracket natin. So, this will be equal to 2 over n times the summation from I equals 1 to n of 8i cube over n cube minus the summation of I equals 1 to n of 12i squared over n squared plus the summation from I equals 1 to n of 3. 3 lang. Now, what we'll do next is consider na yung dun sa unang summation, no, yung 8 over n cube. Para siyang factor ng lahat ng I squared. So, like, 8 over n cube times 1 cube, I meant I cube, plus 8 over n cube plus 2 cube, and so on. So, we could factor it out. So, we could write it as 2 over n times the quantity 8 over n cube times the summation from I equals 1 to n of I cube minus, so same, ilalabas ko yung 12 over n squared minus 12 over n squared times the summation from I equals 1 to n of I squared plus, ano ba yung summation from I equals 1 to n ng 3? So, 3 plus 3 plus 3 plus 3, n times. So, that's just equal to 3n. Diretso na natin siya doon. Now, we'll take advantage na naman, no, of some summation formulas, although I don't have a video for the summation of cubes. But again, if we use proof by induction, itong sum of I cube from I equals 1 to n, this will be equal to n times n plus 1 all over 2 quantity squared. Na expand natin siya, that will be equal to n to the fourth plus 2n cubed plus n squared all over 4. Then yung ginamit natin kaninang summation of squares, this is equal to n times n plus 1 times n plus 1 all over 6. Again, expand na rin natin siya. So, equal siya sa 2n cubed plus 3n squared plus n all over 6. I should stop using this blue color kasi hindi ko na rin makita sa screen ko. Tumitingin na ako sa kodigo ko. Let's just use these formulas, derecho, and we'll get that our expression is now equal to, okay, wait, saan galing yung 16 over n to the fourth? So, pinasok ko yung 2 over n, minultiply ko sa 8 over n cube. So, we'll have 16 over n to the fourth times n to the fourth plus 2n cubed plus n squared all over 4. As yung second expression natin, yung negative 12 over n squared, i-multiply ko na dun sa 2 over n, we'll get negative 24 over n cubed times yung sum ng I squared, which is 2n cubed plus 3n squared plus n all over 6 plus 2 over n times 3 over n, so we'll get 6n over n. So, let's simplify muna what we can. So, 16 and 4, magka-cancel out, 24 and 6, tapos yung n over n. And what we'll get here is, pag dinistribute natin yung over n to the fourth power, yung first parenthesis natin will just be equal to 4 plus 8 over n plus 4 over n squared. Then, yung second parenthesis natin, isasama ko yung negative sa pag-distribute para plus gagamitin ko. Plus negative 8 minus 12 over n minus 4 over n squared. Okay, plus 6 na lang dun sa last term. So, adding like terms, we have 4 plus negative 8 plus 6. That will give us 2. Tapos, yung 4 over n squared, tsaka negative 4 over n squared, magka-cancel. So, yung 8 over n minus 12 over n, so they'll add up to negative 4 over n. So, we'll get that the Riemann sum is equal to 2 minus 4 over n. Again, we are looking for the definite integral, and the definite integral is the limit of the Riemann sum as n approaches infinity. So, the definite integral from 0 to 2 of x cubed minus 3x squared plus 3, this will be equal to the limit as n approaches infinity of 2 minus 4 over n. So, 4 over n, yun lang yung term na may n. At if we let n approach infinity na nasa denominator siya, that whole term will be equal to 0. So, this is just equal to 2. So, the definite integral from 0 to 2 of our given na x cubed minus 3x squared plus 3 will be equal to just 2. So, balikan natin yung figure, no? If you take a look at it, hindi natin talaga siya ma-measure ng geometry area formulas natin. Kasi yung boundaries niya curve. But, na-solve natin siya at kahit yung boundaries niya ay curve, yung region na yan, yung net area, yung positive plus yung negative, they will add up to an integer 2. So, I think that's sort of amazing that we have this region that we can't really cut into squares neatly or rectangles, but we're able to measure it very accurately that it's only an integer value. So, that will be our last example for this discussion on the definite integrals. Salamat sa pakikinig.